Understanding these differences can give you a much broader perspective, almost philosophical, on database design itself.
You've hit a crucial point there. While the ANSI SQL standard defines the what phenomena each isolation level prevents it, very deliberately doesn't mandate the how. And that flexibility lets different database vendors implement concurrency control using fundamentally different architectures, which leads to significant distinctions. The core difference really boils down to two main models, almost opposing philosophies, you could say. Pessimistic locking, that's SQL Server's default world, as we've seen. It assumes conflicts between transactions are likely, so it proactively uses locks to stop transactions interfering. Need to read, take a shared lock. Need to modify, take an exclusive lock. Others wanting that data have to wait. Pessimistic about contention, right? Multi-version concurrency control. MVCC. This is the optimistic model, used widely by Oracle, PostgreSQL, MySQL's InnoDB. It assumes conflicts are less likely. So instead of locking data just for reading, it creates versions, consistent snapshots of the data for transactions. When a transaction reads, it reads from a snapshot that existed at some point in time. Crucially, it does this without taking locks that would block writers. Writers, meanwhile, create new versions of rows, usually without blocking readers, because readers are looking at an older version anyway. This dramatically improves read concurrency. It's a fundamentally different approach. So let's see how SQL Server's traditional default stacks up against these MVCC players. 5.1 Oracle. Default behavior. Oracle's default is read committed. Sounds the same, right? But the implementation is key. It uses MVCC fundamentally. When you query in Oracle, you read from a snapshot of data committed when your query began. This versioning is handled internally, mostly using things called UNDO segments to store those prior versions. Key difference. In Oracle, by default, readers never block writers. Writers never block readers, period. Baked into the core design, this behavior. It's conceptually identical to what happens when you explicitly turn on read committed snapshot, RCSI, in SQL Server. So what SQL Server offers is an optional, really beneficial enhancement. Oracle just gives you out of the box as the default. Pros, cons. You get excellent concurrency right away, fewer reader-writer blocking headaches by default, the trade-off. Well, there's overhead managing those UNDO segments where old versions live. And you can potentially hit snapshot too old errors if a really long transaction needs a version that's aged out of UNDO. Requires careful sizing and monitoring of that UNDO table space. 5.2 PostgreSQL. Default behavior. Like Oracle, PostgreSQL is built on a solid MVCC foundation, its default level. Also read committed. And similarly, its MVCC means readers and writers generally don't block each other, just like Oracle. Key difference. PostgreSQL is pretty strict about dirty reads. It doesn't even have a read uncommitted level in its standard implementation. Try to set it, it just treats it as read committed. It prioritizes data integrity highly. Pros, cons? Again, high concurrency is the default. Makes it performant out of the box for many workloads. Known for being very standards compliant. The main management overhead. Something called VCU. It's a background process needed to clean up old dead row versions left behind by MVCC. If VCU isn't managed well, not run often enough, auto vacuum not tuned right, you can get performance degradation, storage bloat. Requires some attention. 5.3 MySQL, InnoDB engine. Default behavior. Okay, here's where MySQL, specifically with its main engine, InnoDB, throws a curveball compared to the others. InnoDB's default isolation level is repeatable read, not read committed. Key difference. By defaulting to repeatable read, InnoDB gives you a transaction level snapshot right from the start. Your transaction sees the same data for its entire duration, preventing non-repeatable reads by default. This offers stronger consistency guarantees within a transaction than the read committed default of the others. It's almost like MySQL and InnoDB is saying, I value consistency across your whole transaction above all else by default. Pros, cons. That stronger default consistency can be good for some apps, but it can also surprise developers coming from other databases. It means your app might read stale data for longer in a long transaction because it won't see changes committed by others until its own transaction ends. For many web apps where you often want statement-level consistency and to see committed changes quickly, it's actually pretty common practice to explicitly change MySQL's default down to read committed to get that more typical behavior seen in Oracle and Postgres.
Wow. So looking at that comparison, SQL Server's default, that locking base read committed, it really does stand out as a bit of an exception among these popular modern RDBMSs, doesn't it? Most others default to MVCC. So is SQL Server kind of behind here? Or is there maybe a strategic reason for this different default approach?
That's a great question, and it's important not to see it necessarily as a weakness, but more as a different architectural choice that actually offers tremendous flexibility. While SQL Server's default is traditional locking, remember those explicit row versioning levels we talked about, read committed snapshot, RCSI, and full snapshot isolation. These give DBAs and developers the power to choose. Do you want traditional pessimistic locking? You got it. Do you prefer the optimistic MVCC approach? You can enable RCSI or use Snapshot. SQL Server gives you robust tools for either model. This fine-grained control, letting you pick the best model for different parts of your application, or even enable RCSI database-wide, that's actually a significant strength. It offers adaptability that can be incredibly powerful in complex environments.
Okay, so armed with all this fantastic deep knowledge, isolation levels, locking, MVCC, comparisons, what does it all boil down to for you, the cloud database professional? When you're actually in the trenches, designing systems, troubleshooting performance, what are the really pragmatic, actionable recommendations we can walk away with? This is where the rubber meets the road, right?
Absolutely. This is about translating all that theory into practical, impactful decisions day to day. Let's summarize some key best practices. Action proposed for the cloud database professional. Favor read committed snapshot, RCSI, over NOLOCK. Cannot stress this enough. If you're hitting reader-writer blocking issues, RCSI is almost always vastly superior to sprinkling and NOLOCK everywhere. Enable RCSI at the database level, it stops the blocking, gives you statement-level consistency, no dirty reads, and keeps your code clean. Yes, it uses more temp to beep, but that trade-off, usually well worth it for the huge concurrency boost and responsiveness gains in OLTP systems. It's often a foundational improvement. Action proposed for the cloud database professional. Use locking and isolation hints as a last resort. Remember, SQL Service Query Optimizer is smart, really smart. It usually makes good locking decisions based on stats and query structure. Don't jump to force locking with hints. Lock, paglock, tablock first. Always investigate the fundamentals first. Missing indexes, fragmented indexes, outdated stats fooling the optimizer, poorly written queries, long-running app transactions. Fixing those root causes is nearly always better and more sustainable than just slapping on a locking hint band-aid. Hints are precision tools, use them surgically if at all. Action proposed for the cloud database professional. Treat Serializable and Snapshot with extreme respect. These are powerful, yes, but they've significant overhead and side effects. Handle with care. Serializable. Only use it if you have an absolute, undeniable business need to prevent phantoms like critical auditing. And only after rigorous testing for blocking and deadlocks. Its range locks can kill concurrency. Full snapshot isolation. Great for long reports needing a consistent view from the transaction start, but be very aware of potential update conflicts. Your app must be ready to handle the error if it tries to update data that's changed since the snapshot began. Error handling and retry logic are essential here. Action proposed for the cloud database professional. Be explicit and defensive in your application code. Remember those external influences. Connection pooling, framework defaults, they can bite you. So don't assume the default isolation level is always active. Be defensive. Explicitly set the level you need at the start of critical transactions. Set transaction isolation level read committed, or whatever fits. If you're using things like .NET Transaction Scope, explicitly set its isolation level parameter away from the serializable default unless you truly need it for that specific block. Audit your frameworks. Know their defaults. Control them. Defensive coding prevents so many headaches later. Action proposed for the cloud database professional. Never use NOLOCK and data modification statements. Just don't. It's a simple, non-negotiable rule. The optimizer ignores NOLOCK read uncommitted on the target table of an update or delete. Has no effect there. Offers false hope. Using it in insert statements. Strongly advised against. High risk of inconsistency. And that syntax support is officially deprecated anyway. It will be removed. So just avoid it completely in DML. Full stop.
Wow, what a deep dive indeed. It is crystal clear that managing that constant tension, concurrency versus consistency, it's one of the most challenging parts of database management today, but absolutely crucial. It's definitely not a simple on-off switch, is it?
It truly isn't. You know, a seasoned pro gets that the goal isn't really to eliminate locking altogether. Locking is necessary. It protects data integrity. The real goal is to manage it intelligently. That means choosing the least restrictive isolation level that still meets your business needs for consistency. No more, no less. It means leveraging modern features like RCSI safely to solve those common blocking problems without introducing risk. And it means treating query hints with extreme caution. Like surgeon's tools, only used when the optimizer's default is proven wrong and you've fixed all the underlying issues first. It's about being a detective, really, not just a mechanic.
And by mastering these nuances, you really do move beyond just writing T-SQL that happens to work. You start genuinely architecting scalable, robust, correct data solutions. Solutions that can stand up to the increasing demands of the real world. That's the difference, like you said, between building a house of cards and building a skyscraper. So thinking about your own systems, especially as data volumes keep growing, user loads keep increasing. What are your go-to strategies right now for managing concurrency and blocking? Are you maybe still heavily reliant on NOLOCK because, well, that's how we've always done it? Or have you fully embraced the power and safety of something like RCSI? Definitely something to mull over until our next deep dive.
Don't miss out. Smash that like button, subscribe, and explore our other videos in the playlists.